Alright, so today is some more work on proving geometric relationships. So all the problems today are proofs. The good news is there's 6 problems, so it's short, but also the good news is 4 of the 6 are fill in the blank, which are much easier. Not that they're easy, but it's much easier to do those typically. So remember that our steps, if you will, for doing a proof is we are going to write the given. I always say make conclusions. From the given information. I'm glancing through the assignment, and I don't think you're going to have to do that. Yeah, there's nothing that you'll have to do that, but that'll come into play in later chapters. So then number 3, and really for the rest of the proof until the very end, use properties, postulates, theorems, definitions, to add to the problem to make your argument. And then after you've done that, and then that might be 2 or 3 different steps, you should have the proof statement at the end. Okay, so that's important that you know those steps. Okay, so let's look at one. So if I'm given that AB is congruent to CD, and I want to prove that AC is congruent to BD. So by looking at it, so what I'm told is AB, this part, and CD are congruent. Then I'm trying to prove that from A to C is the same as B to D. So you might be able to just go, well, if the 2 little parts are the same and then they both share that BC part, then yeah, they're going to be congruent. So, I mean, you can kind of visually see that sometimes, but we got to figure out how in the world do I write that down. Okay, so step 1 is just to write the given. So remember, and then over here we ought to do our reasons. How do I know that that's true? Well, it was given to me. So literally on any proof problem, if you miss the first step, I don't know what to tell you. It's always the given. And the book sometimes will, if there's more than one piece of given information, they might write it as one step combined, or they might write it as step 1 and then step 2, and they're both given. And you can do it either way. That part doesn't matter. So step 2 is make conclusions about the given, but when stuff is just congruent, there's no conclusion to make. It's just congruent. So sometimes it might say something bisects. then your conclusion is, well, then each part is congruent. Or something is perpendicular. We haven't really talked a lot about that word, but then your conclusion is, well, those are right angles, because perpendicular lines make right angles. So there's different conclusions you can make, but that's not really going to come up today. Well, there is on one. If it says they're supplementary, then your conclusion is that they add up to 180 degrees. And that's just the definition of supplementary angles. But all right, so back to this one. No conclusion to make. So now I need to use properties, definitions, theorems, postulates. Okay, and so one of the things is, like, at the end, I want AC and BD to be congruent. But I don't have any information about AC or BD, like, in the problem. So on problems like this, you're going to use, on this one, because it's a segment, you're going to be able, you can introduce AC as AB plus BC, which is segment addition. And you can do the same thing with angles. If it doesn't, like, if it's not there in any way, shape, or form, you can introduce what you want by saying, well, this bigger angle is this angle, these two smaller angles added together. Okay? So I introduced AC, and I can introduce BD the same way, by saying that it's BC plus CD, and it's segment addition. So if you wanted to do that as step 2 and step 3, you could, or you can if you're going to use segment addition like twice, you can combine it into one statement, and then, because it's the same reason, that's your decision. I tend to just write them out as separate, but it's not a big deal either way. Okay. So in the end, again, I want that and that to be equal or congruent. So what I also notice is that, well, I have BC in both equations, but then AB and CD are different. So if I could make either BC or CD be like the same, then I'm good. So that goes back to step 1, where they're told you it's congruent. So if anywhere I see AB, I can replace it with CD, or the other way around. Doesn't matter which. So I'm just going to do it in this last one, the step 3 like one. So I can say BD equals BC, and then instead of putting CD, I know up at the top, like up here, they're the same. So I can put AB in its place. And that is the substitution property. Okay, and so now if I look at BC plus AB, AB plus BC, that's the same thing, just the order's different. Well, if those are the same thing, then I can say that AC equals BD, and that is transitive property. I would accept substitution on that one also. Both of those I think are correct. Okay. And then there's kind of a weird thing, like, in the end, what I'm supposed to do, if you go all the way back up to the top, to the prove part, it says that they are congruent, but what I have is that they are equal. So you have to actually do this extra step to say that they are congruent, not that they are equal. And what that reason is the definition of congruent. definition of congruent is they are equal. So you can go back and forth. I'm not a huge like stickler on that one, but if you check your answers in the book and you see that definition of congruence thing, I wanted you to at least have some indication of what's happening. Okay, so there is a problem that you'll have to do that is very similar to this one, except for it uses angles instead of segments. So this is a good model to use when you're trying to figure out that other one. Okay? But you know, all the properties that we talked about, you can see like transitive and substitution in this chapter are ones that get used a lot. Okay? So you are going to need to use, there's a couple problems that talk about complementary angles. There's a problem or two that talk about supplementary angles. And then honestly, like the rest of them are really going to be, you're going to almost use transitive and substitution on almost all the problems. Not 100%. Not like you're going to use probably one or the other on every problem, and sometimes both. So those are kind of like your targets for if you're not quite sure what to do. Oh yeah, and then angle addition. And really this one is to introduce angles not already in the problem. So if you're using transitive and substitution, the information that you need is already there because it was given to you, or some other step that you did before. So one of the clues also is if things, like anything, if something's congruent in the given, you're going to probably use substitution somewhere. It's just the way that it like works, or it could be a transitive situation. So when something is congruent in the given, like that one that I just did, you're going to use substitution or transitive potentially, depending on the problem. But usually that indicates a substitution. Okay, so do the best you can here. I'm anticipating that there's going to be questions the next day, so please stay so we can go over stuff if you have questions. But when we get around to taking a test, the proofs will be all fill in the blank, so that is much easier than having to come up with stuff on your own. So okay, try to knock those out. 6 problems, hopefully it's not too agonizing, but and then come back tomorrow with any questions you have. Have a great day.